Let's take a look at Achieve section 310, number 13. Again, a related rates problem here. Similar in a lot of ways to the other problems in this section that I've done videos for. A police car in this case is traveling south toward, this is Sioux Falls in Iowa, I think, at 160 kilometers per hour. And it pursues a truck traveling east away from Sioux Falls at 140 kilometers per hour. And they give a little diagram here. You have the police car. Sioux Falls is this little red asterisk here. The police car is moving south, so we've got south going down in our diagram, right, at 160 kilometers per hour, and then heading east, right, away from Sioux Falls. This truck here is moving to the right, which is to the east at 140 kilometers per hour. They go ahead and give you the distance X that the truck is from Sioux Falls and the distance Y that the police car is from Sioux Falls. They give you that. I've labeled the distance between the vehicles L. That's not in the original diagram. As we read through the rest of the problem, then at time t equals 0, the police car is 50 kilometers north. So this distance initially at t0 is 50 kilometers, and the truck is 30 kilometers east, okay, of Sioux Falls at time 0. Calculate the rate at which the distance between the vehicles is changing at t equal 5 minutes, and then round answers to 3 decimal places. So we're going to use the ideas that we've developed with related rates. I do need to indicate, I want the rate of change of this distance, so I need to indicate this distance with a variable. I'm calling it L. That's the distance between the truck and the police car. Okay, so again, very contrived problem, simplified. We're assuming that the police car will continue to move in this direction, the truck in this direction, but that's going to make us be able to do this problem. You'll see I put a right angle in here, right? This would have to be right angle if this direction is due south and this direction is due east. They're at 90 degrees from each other. And we again have a right triangle. And so the relationship between the variables x, y, and L are given by down here, right, the Pythagorean theorem. What information are we given in terms of rates? Well, we're given that dx dt is 140 kilometers per hour. Here's x. The truck has a velocity of 140 kilometers per hour. So x is changing at that same rate. And notice x is getting bigger. The truck is getting further away from Sioux Falls, right? So dx dt is positive. dy dt is negative 160 kilometers per hour. Why is dy dt negative 160? Well, as the police car gets closer to Sioux Falls, what's happening to the value of y? It's getting smaller. And so therefore dy dt has to be negative. Your rate of change has to be negative. You have to be able to put that negative rate of change on the given quantity here. That's very important. That's why it's so crucial to make sure you draw the picture if it's not given, clearly label your unknown distances or quantities, and you know, think about what's happening as things move and change with respect to one another. Okay, with that, we're going to find dl dt. That's the rate of change of the distance between the vehicles at t equal 5 minutes. So we differentiate with respect to time, both sides of our equation here. Both x and y and also L, all 3 of these variables are not constants with respect to time. They are all changing with respect to time, right? This is changing, and the distance between the vehicles is changing. So chain rule, when we find the derivative with respect to t of x squared, derivative of the outer function x squared is 2x times the derivative of the inner function dx dt. The derivative of y squared is 2y dy dt, and the derivative of L squared is 2L dl dt. Divide both sides of this equation by 2, and then solving for dl dt, I'm going to divide by L both sides, or multiply by 1 over L. So it's 1 over L times x dx dt plus y dy dt. So I've solved for dl dt. So now I know what dx dt and dy dt are. Those are my given rates. But what about the values of x, y, and L? Well, we're finding it now at we're finding dl dt at t equal 5 minutes. So first of all, we need to know, we know what's happening at time 0. So we know initially, for instance, the police car is 50 kilometers north. And so the value of y is 50 initially. And then obviously what's going to happen to y? It's going to get smaller. right? So it's going to be less than 50 kilometers. X initially is what? 30 kilometers east, right, at time 0. And then notice that as time 5, a little bit later, it's going to be a little bit more than 30 kilometers. So what I did here is, first of all, notice we're given time in minutes and rates in kilometers per hour. You have to have consistent units. So you're either going to have to convert these speeds to kilometers per second. You could do that. Or I think much easier, convert your time from minutes to hours. So 5 minutes times what? There's 1 hour and 60 minutes. So this is a unit conversion factor that'll change to hours, right? In other words, divide by 60 to get the number of hours. So 5/60ths of an hour, which applies to 1/12. So 1/12 of an hour is what 5 minutes is, right? So that's what we're going to have to use to find the distance traveled. So first of all, the truck, right? Speed 140 kilometers per hour, dx dt. So 140 kilometers per hour times 1/12 of an hour gives me 35 thirds. The units are going to be kilometers, right? Since the hours cancel. So that's what it's going to be, which is about 11.667 kilometers. That's how far basically the vehicle traveled in those 5 minutes. So what is its, what is the value of X at 5 minutes? We know initially it was 30, right? Again, 30 kilometers east. So at time 0, this is 30. And then we're going to add what this 11.6. So it's going to be about 41.667. Now I'm going to use the fractions, and you can just use your calculator's convert to fraction command if you want to here to help with that. I don't want to round off any intermediate results. They told us to round to 3 decimal places. If you round too much, you can get a wrong result. If you are going to round, I would carry it out at least 4, maybe 5 or 6 decimal places, even more, because we're going to use these values to compute L down here, and error propagates and you can be off in your final answer. Ideally, it's best to leave it in fraction form, which is what I'm going to do, 125 thirds. Then what about the police car here, right? It's coming down at 160 kilometers per hour. Initially, it's 50 kilometers north. So its rate, remember, is negative 160 to indicate that y is getting smaller. So negative 160 times 1/12 simplifies down to negative 40 thirds. And I'm actually going to subtract, therefore, right? It's negative 50 minus 4 thirds, right? Because it's y is less, right? It's now 110 thirds, right? And you can, see that that's less than 50 kilometers. So that's the value of y. So I've got X and Y at the time 5 minutes. So what's L going to be? Well, from this relationship at any point in time, I can find L. Just take the square root, right, of X squared plus Y squared. And so L is going to be X, which is 125 thirds squared, plus Y, 110 thirds squared. So that expression will give me the value of L. Whoops, I've got L squared here. This should be just L. Sorry. L is that, not L squared. So L is this number. So now I can plug in. Okay, so dLdt is 1 over L. I just put an asterisk here, where asterisk is this number. So I'm going to plug that in there. X was what? 125 thirds. Dx dt we know is 140. Y was 110 thirds. Dy dt is negative 160. So you just need to evaluate all this, and that comes out to be that. So when I'm doing it in the calculator, you can see what I've done here. Let me just do actually entry here so you can see it. I entered it in everything without any rounding. Okay, so I had 1 divided by L, right? L was this stuff over here. So I have the square root of 125 thirds squared plus 110 thirds squared, right? That's the square root. So all of that, 1 divided by that, 1 over L, times, and then in parentheses, oops, down here, times in parentheses, I've got, get over here, 125 times 140 divided by 3. That's this number here. And then I did minus because it's plus, this will be negative. So I just did a minus, plus a negative is going to be minus 110 times 160 divided by 3. Okay, all that craziness, right? And we get that result, which notice, be careful about rounding, right? This is very close, right? Since this is a 5, we're rounding to 3 decimal places, so this 0 gets rounded up to a 1 because the next digit is 5 or more. If this was, a 4, then it would just be negative 0.600 to 3 decimal places. So instead it's negative 0.601. And the units are going to be kilometers per hour. You can analyze all the units in these numbers, but we know the speed is going to be in kilometers per hour. So that is the answer that they're looking for. And at any rate, the numbers are a little wonky here, a little crazy, got to keep track of a little bit, but hopefully the process makes sense. If you have questions about this problem, please let me know. So I hope this helps you with this.